Hello friends, this video on electrochemistry part 3 is brought to you by examfear.com. No more fear from exam. So before we discuss all the reactions further, I think you're having some doubts in understanding the voltaic pile. Let's understand the concept of metals. Why do they oxidize? For example, I told that zinc became Zn2 plus. Correct? In the earlier voltaic pile, and H plus becomes H2. Why it happened? Why zinc gave its 2 electron to become Zn2 plus, and why H plus took electron to become H2? See, if you see in the real world, right? I mean, if you see three examples here now, this is Santa Claus, this is a small girl, and this is a poor person. This is a poor guy, right? So if Santa Claus has a gift, he can give this gift to poor girl, or he can give this to a girl or to this poor man. Similarly, if the girl has a gift, she can gift it to poor man, but she won't give it to Santa Claus. Santa Claus won't accept gift, right? If the poor man has something, or food actually, the poor man will eat on its own. He will not share with anyone because he doesn't have. The only thing he has is the food, right? So Santa Claus is the one who always gives. So if you talk about Santa Claus and the girl, who will give? Santa Claus. If you talk about the girl and the poor man, who will give? The girl. If you talk about the Santa Claus and the poor man, who will give the gift? Obviously Santa Claus. Right? Same thing applies in the real world. For example, if you assume Santa Claus has zinc, this poor girl has copper, and this girl has copper and the poor man has silver. Now, let's see the zinc. The atomic number is 30, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2. So if you see, the outer shell has 2 electrons. That means zinc is not stable, but zinc 2 plus is more stable. This is more stable. Why? Because the moment zinc has given 2 electrons, it is more stable. Similarly, right, Santa Claus has more gifts. He won't be happy with so many gifts. He want to give away, right? So he'll be more happy by giving the gift. Similarly, zinc will attain more stability. Same applies with copper and silver, but you have seen that in the atom chapter, right? The number of shells increase, the force of attraction with this valence electron in the nuclei plays a role, right? So the tendency of an element to give electron or take electron depends on a lot of factors. For example, chlorine will always want to go to Cl minus stage. That is, it will want to take one electron, right? Sodium will want to go to Na plus state. It will want to give electron because, and this is more stable, this is more stable. So everybody want to be stable, right, in the life. So to attain stability, they either give electron or lose electron, and that is the reason behind the whole chemistry, right? It's all electron which plays a critical role there. So here also, zinc will have more tendency to give electron, copper will have less tendency, and silver will have all the more less tendency to give electron, right? I'll not discuss why. It all depends on the structure, on the number of shells, and the distance they have from the nucleus. If you want, you can understand, or you can go through the video of the atoms where we explained all these concepts, right? So the only point I'm trying to achieve from this slide is zinc, silver, and copper, they all have different tendency to lose electron. It's not that they all have same tendency, right? Zinc has more tendency. Then if you take gold is even less reactive. They'll have all the more less tendency to give electron. Correct? So that is what I'm trying to say. For example, in this case, I have zinc and copper sulfate. So zinc has tendency to give more electrons. Zinc will become Zn2 plus, and copper will become copper. So zinc has more tendency to give electron. So since zinc has more tendency to give electron, so if you are having reacting zinc with Cu2 plus, so Cu2 plus can be my copper sulfate solution, right? So it will become Zn2 plus zinc sulfate solution. So since zinc has more tendency to give electron and become Zn2 plus. But the reverse reaction, if you have, you take copper and you, for example, same thing also, copper and silver. Now this was zinc, this is copper, and this is silver, correct? So zinc and copper, zinc will try to become Zn2 plus. Copper and silver, copper will try to become Cu2 plus, correct? So copper will become Cu2 plus. So silver has to, if copper is oxidized, somebody has to reduce. So silver will reduce to Ag plus will reduce to silver. So we can take it AgCl, this becomes CuCl2. But the reverse reaction won't happen. For example, if you take Zn2 plus and react with copper, and you expect it becomes ZnCu2 plus, that won't happen. Why? Because zinc won't try to become Zn, right? Zinc want to give electron. If you compare zinc and copper, so if you compare zinc and copper, it is zinc which will try to get get oxidized by giving electron. So zinc will try to get oxidized. Here zinc is getting reduced, right? And that is not possible. So this reaction won't happen. Please understand, it's a very critical topic here. If you understand this, it's almost 30% of electrochemistry. If you talk about the reaction between zinc and copper plus, zinc will, if you talk about zinc and copper, zinc will have tendency to become Zn2 plus, oxidize. So, more than copper, because zinc and copper, I'm telling you that zinc has more tendency to give electron, correct? So the moment you talk about zinc and copper reaction, it will always zinc, it will try to become Zn2 plus. Since zinc becomes Zn2 plus, this copper should be reduced, right? So this has to be, let's suppose, copper 2 plus, then it becomes copper, correct? But the other way reaction won't happen. If it is already Zn2 plus and you react with copper, this won't happen. Zn2 plus won't go to Zn. Between zinc and copper, zinc has more tendency to give electrons. Same thing between copper and silver, copper has more tendency to give electrons. So copper will have tendency to become Cu2 plus. These two reactions will happen and these reactions won't happen, right? So if we talk about the competitive transfer of electron, this is the series we have. So if you see, zinc will be somewhere here, there is copper somewhere here, and this silver is somewhere here. For example, if you talk about the lithium and potassium, so then lithium will become Santa Claus and potassium may become the girl, right? So the one on this side has more tendency to give electron. So lithium has maximum tendency, then potassium, then calcium, then sodium, and these are based on the distance of electron from the nucleus. So for example, if you see, this atomic size is less and this is bigger size. So I'll not go details into this why this is the metal activity series, but I think we have covered this in one of the atom chapter where we have discussed the series and we have told why is this series applicable. Please watch that video if you have any doubt in this. So let's see what happens if you put zinc in copper solution, right? So zinc is there and you have a copper solution. Copper solution is copper sulfate. Let's say copper sulfate is blue in color, right? Little dark blue. Dark blue copper sulfate solution. And this is the color of my zinc. I take zinc in copper sulfate solution. Now zinc and copper, if you compare, so this is my zinc and this is my copper. So zinc has more tendency to become Zn2 plus, so zinc will try to become Zn2 plus. Since zinc is oxidized, copper has to get reduced. So copper plus becomes copper. So what will happen in this case? You will get zinc sulfates in this solution, right? And the copper sulfate becomes copper. So if you see, what will happen is, in this case, what will happen is, see, this is what will happen. The copper sulfate become lighter in color, and the copper from this copper sulfate has joined this zinc. See, the copper sulfate from the solution became the real copper and it got deposited in this over zinc. Correct? But if you take other way around, as I told, zinc sulfate or Zn2 plus and copper, there will not be any reaction. Why? Because between zinc and copper, it is zinc who want to give electron, who want to get oxidized. Zinc is already in +2 state, it can't get oxidized to a higher state. And if you want to know why, again we have discussed this where we talk about different oxidation state for a given metal. For zinc, Zn+2 is the oxidation state, it can't go higher. So there won't be any reaction. Hope you understand. So zinc in copper solution, yes, there will be reaction. Copper in zinc solution, no reaction. Why? Because of the metal activity series. So before I start this chapter on battery and electrochemistry, we will a lot of time will talk about this oxidation and reduction, right? And oxidation will happen at anode and reduction will happen at cathode. So people students generally confuse, right? Anode sometimes reduction, cathode oxidation. This is a confusion, but this is what happens, right? Anode is oxidation, cathode is reduction. To understand this, I just gave a memory tip. Just remember this figure. This is an ox because there is an ox and there is a red cat here. This is a red cat. So red cat. The moment an ox see a red cat, it starts running, right? So there is a relationship between the red. You must be knowing, right? When the ox see red color, it will start running. The relationship between the red cat and the ox. The moment you think of an ox is running after a red cat, right? Or you can just remember the statement: an ox running after red cat. So red cat is what? Red means reduction and cat means cathode. N means anode, ox means oxidation. Correct? Reduction is cathode, anode is oxidation. Reduction is cathode, anode is oxidation. Please note, this is a very critical memory tip because a lot of students get confused with the anode and cathode, where reduction will happen, where oxidation will happen. This is a very good, pretty decent memory tip, right? So anode oxidation, anox, reduction, cathode, red cat, anox. Just think of this figure, a red cat being chased by an ox. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.